Well, hello everybody, this is Mr. Paulo Mean. So if you're watching this, you're probably one of my 7th grade math teachers. I'm making these YouTube videos public. So if you're watching this, you either open the QR code in this right hand corner, or you're looking at the video from the Google slide that's here. And so the video is somewhere in this area. All right, so I'm going to be modeling solving two-step linear equations using algebra tiles. The state assessment will give you questions like this, where the kids will see a pictorial representation of the problem, then it can be expected to find a solution. This only works. Our student success will only work with these kind of representations if and only if we use the actual tiles. Okay, so we need to make sure that they know how to solve with tiles. So they're going to have to know, what does this mean? So this is my representation of 4x plus 6 equals 13. And so I'm just going to copy it over here in Polypad. So those 4 x's, so I'm going to use my mouse because sometimes my pen doesn't work too good. 1, 2, 3, 4 x's. Get it? So these are my 4 x's, and they're here in the Polypad. They're rectangles, but they're x's. And then it was plus 6, I think. Was it plus 6? Yep, it was 6. So I'll come over here, and then I'm just going to make copies of it. Highlight over the 3, make, never mind. So here's through again. So copy, highlight over the 3, copy, and then move it over, and there's your 6. We use a little line here as our equal sign, and then it's 13. Okay, so I can make a copy of this guy, copy. Here's my 6, copy again, and my mouse is getting really, really moody, so there should be 12 ones here. I don't know if I'm going to get all 12. I'm going to find them. We're going to look for them, right? They're here somewhere. There they are. Yay. So it's 12, and then one more. 13. Okay, so I should be able to use my pen now. Let's see if it works or not. Yeah, I don't move things around. So the rules are this. I'm going to isolate x. If you're watching this and you've gone through the Sandra Garza trainings, I know she mentions that it doesn't matter where the x is. For the purpose of solving with algebra tiles, I want the x on the left side. Later, we can tell the kids, yeah, it doesn't matter where it's sighted on. X equals 4 is the same thing as 4 equals x. Good. But we'll get to that in a little bit. In the meantime, we're going to just try to start getting our kids versed in being able to solve for a variable. I need them to put x on the left side, our regular numbers, whether they're whole integers or whatever they are, on the right side. Okay, so the way I see it is this way. The way I tell my students this way. I want to get rid of this plus 6 on this side. I don't want them over here. So what I do is I'm going to bring in a negative value, right? Here's my negative over here. And I need to cancel out every single one of these guys on this side. So you'll notice how they're kind of disappearing. How many do I need to put on this side to cancel out everything here? Well, 6. Negative 6 in this case, right? But what I do to one side, I'm going to have to do the other. And I don't just say it. We have to give them an example of why it works. And the reason I give them is if I'm going to be, for example, like lifting weights or something like that, and I take out 2 pounds from one side of my weight, I need to be able to take the same amount out. There's a 6 in here somewhere he's hiding. Let's see, there he is. So this mouse right now is getting really, really moody. And it's been doing that lately because I'm using a new laptop, and it's just not the best one in the world, but it gets the job done. So if I have weights, for example, if I have a dumbbell, I see how the thing here doesn't want to work. Interesting. Oh, there's because I had the eraser on. If I have weights, right, and over here I got a 5-pound dumbbell, and over here I got another 5-pound dumbbell. Then I got a smaller 2-pound one here, and a smaller 2-pound dumbbell out here. If I remove this one, this guy's going to tip over this way. So if I remove 2 from one side, I got to remove 2 pounds from the other side in order to keep my dumbbells, even Steven, right? Balanced. So that's what we're doing here. To keep everything balanced, if I remove 6 from one side, I got to remove 6 from the other side. And I'm sorry for the coughing, but I'm not going to redo these videos again. So on this side, I am going to cancel out 6 on this side. So you got, these are called 0 pairs, by the way. And they're gone. And over here, all these guys will also form 0 pairs, and they'll be gone. So if you're a student watching this, what you're doing is you're going to remove 6 from one side and 6 from the other, only if they're like the same thing. I don't know if you notice that. If this guys were red, would have a different thing going on. But don't worry, we'll do plenty of examples. What I got left now is I got 4x equals to 1, 2, 3, 4, 5, 6. So I want to evenly distribute or evenly divide my integers on this side with the 4x's over here. So in other words, he's going to get 1. He's going to get 1. He's going to get 1. And he or she's going to get 1, right? I have I did 7 because it was 13 on this side, 13 ones on this side, and I took out 6. So these me a 7. So I don't have enough to do one more completely. So now the question is, okay, so I got this value and I need to divide it into 4 parts. So what I do with this 1? Well, I can cut it into 4 little parts. 1, 2, 3, 4. And give this guy a fourth of this one. You give each one a fourth, actually. You get a fourth, you get a fourth, you get a fourth, you get a fourth. Cut this guy into 4 parts as well. You get a fourth, you get a fourth, you get a fourth, you get a fourth. Cut this guy into 4 equal parts, and I'm going crisscross, but each of the little triangles are the same size. Get it? You get a fourth, you get a fourth, you get a fourth, you get a fourth. I could have done this with that 1, cut it in halves like this, and say, look, there's 4 equal parts. All right, so each x is getting 1, and then 1, 2, 3 fourths. Now, what does this look like as a improper fraction? Well, see if I get this 1, that 1 equals to 4 fourths, and then plus that 3 fourths that are over here. Get it? It's going to be 7 fourths, or 7 fourths. So x equals to 7 fourths. This is how we write it from now on. In secondary math, we don't really write our answers this way anymore. We're going to leave them as improper fractions, right? That 7 over 4 is good enough. So let's take a look at our answer choices. Is there a 7/4 here anywhere? Yeah, it's right there. So that's my answer. And you can always check your answer. So you can go 4 times 7/4. That becomes 7. 7 plus 6 equals 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 on this side. So yes, it's the right answer. And that's using tiles to solve for a letter. You can get the right answer every single time. You can't fail. Kind of neat, right?